The following presentation is on the interval and radius of convergence of a power series. A power series is an infinite series with a variable. The interval of convergence is the range of values of the variable for which the power series will converge. The radius of convergence of a power series is half of the length of the interval of convergence. Geometric series is a series in which the terms increase by the multiplication of a common ratio. We know that the geometric series is the absolute value of the common ratio. And the radius interval of convergence, that is geometric, first you must common ratio. In this case, ratio is x minus 1 because that is base raised to the we are multiplying each term by increase. So the value of the common to be less than 1. We solve. So of the 5 because the 6 is a length of 10 that distance. You can radius of convergence in the previous step. Or you simplify your absolute value of x minus a number, that's where your rate is going to be. Also find the center series in this form. We must use the ratio test for non-geometric series to find the interval and radius of ratio test. When the radius and the interval of convergence are ratio tests less, that is the value of a ratio test that is as we can. What's left for the limit. So n goes to n x times n over n plus 1 is less than 1. And we are looking at the relationship of the n, so only evaluate going as n approaches infinity. N over n goes to 1, so the only thing we're left with is the absolute value of x is less than 1. Here, we end up with a negative 1/2 to positive 1. We must check the points of the interval to check for a competing series. So the geometric series test, because we have the geometric any ratio that's less. But in this situation, we're not dealing with geometric series anymore, so we need to check by plugging back in original series. Simplify. If 1/2, we end up with a converging, I'll plug in positive 1/2, we end harmonic. Therefore, the convergence is going to include half, exclude positive. Our radius is going to be 1/2 between negative, and our radius is going to be half the distance of interval. Do another example. So again, the first step is to and less than 1 because we are using our series. That's the reason why we are asking simplify as much as we can. Value symbols, I'm going to cancel out series. Simplify the coefficient. Simplify the, and we are left with the following limit. X minus 1 over 3 times n over n plus 2. The n terms are going to have a limit that is equal to 1, so we just focus on x minus 1 over 3 being less than 1. When we solve, we get an interval of convergence of negative 2 is less than x, which is less than 4. Check the endpoints by plugging negative 2 and positive 4 original. Simplify as much as I can. Both converge. One the other n squared using either comparison test. Therefore, the interval of convergence is between negative 2 and positive is 3 because the distance between is 6 and half of 6. Following example, set up our ratio test, just like simplify our variable can, evaluate our limit. This one is different than the previous one because in the numerator, of course, our n over m, the power on the m is greater than the power. The higher limit equals 0. The interval of convergence for the series is to converge, and the radius is going to be infinite as well because of the fact that this variable does not change it at all. No matter what, this limit is